All right, guys. So this video it's probably going to be a couple videos. We're going to be going through a full free response section of the test. So we've already done the practice test number 3, multiple choice. So I've gone through that and just kind of showing you what I'm thinking as I'm going through the test and that kind of thing. And so I want to do the same thing with the free response. So the one I'm doing is going to be the 2019 free response. So this is the free response that my AP chemistry students took at the end of 2019. So the 2018-2019 year. And so, I want you to kind of see exactly what kind of test you'll see. So the other thing is, so I want to go through the test. I want to show you kind of the important things that I have underlined, like, because you're allowed to write on the test, you should annotate it, what to expect, remind you to show your work, maybe show more work than I did. And what I'm going to show you is my responses to this test going as fast as I can. So when I made this answer key that I'm going to show you as we go through this test, I made this answer key. So if you don't know, they release the free response 48 hours after the test. So on Wednesday or Thursday of next week, I'll have the free response that you were given. And what I normally do is when they release that is I get it and I try to make an answer key as fast as I possibly can. I see how long it would take me. And I go as quick as possible. So this answer key might not have all the exact information you need to get full credit, because I might have missed something and I might have made a mistake. I might have overthought something. So I want to kind of show you that as we go through the test to see kind of the common mistakes that you can make when you're rushing, okay? And the other thing I'll say is, if you didn't get my, if you didn't see my update on Saturday, I noticed that a lot of students are feeling discouraged, especially after taking practice test number 1. And just remember, all these practice tests, the practice tests that they release to us are always the international exams, and the international students, they get released, their practice tests are going to be the American exam. And just understand that the curriculum is slightly different. The way they teach it, the concepts, they're not always 100% the same. And so if you're feeling a little discouraged with how you're doing on these practice tests, it might be because the test is slightly different, and it looks maybe a little bit different than how your unit tests kind of looked and what you kind of expect based on what we cover in the class. And so what I posted on Saturday was this folder in your test review folder. So I went back and I got the last 3 free responses that American kids took, that that we took here in America. Obviously the 2021 doesn't really count because that was the weird COVID online year, and 2021 we were online, but the kids took a regular test. But in 2020 it was this weird test that whatever, it doesn't count. So these are the past 2 tests. So in this folder you can see what the kids got last year in the answer key. You can see what the kids got in 2019, and that's what we're going to go over today in this video, and then also 2018. And I think if you look at these free responses, you might feel a little bit better because they'll look a lot, you'll recognize a lot of the questions because I used a lot of the same questions in my unit test. And maybe the style looks a little bit different than the style of the practice test you've been taking. Okay, so don't get me wrong, the practice tests that you're taking are good practice tests. Most of the content is identical, okay? But again, the structure, the wording are always slightly different on the international exam. And so, and I'm not saying the international one is harder than the American one. I'm just saying they're different. So we spent all year gearing up for the American one. So if all of a sudden you're given an international exam, it's going to look a little bit different, and it's going to feel like it's more difficult. But if we had spent all year gearing up for the international exam, then it would look just fine. And then if you took the American one, then it would look different and it would feel harder. So, maybe look at these when you have a chance, especially look at last year's. I used a lot of last year's test on practice that we've done in class this year. And I thought last year's free response was pretty easy. I think that's because a lot of the country was still kind of teaching online instead of in person, and so they might have made it a little bit easier. And so this year, I would expect it to step up a notch. So if you want to see what it could possibly, the difficulty level that it could possibly be this year, look at the 2019 and look at the 2018, because that was pre-COVID and we were all, firing on all gears there, okay? All cylinders. All right, so let's get into the 2019 free response, okay? So this is what the test looked like. I'm gonna show you, I'm gonna work through kind of the annotated one, and I'll show you what I wrote down on my key, and then I'll talk about what I think my key might be missing, all right? So here's what it looks like. So we get given this structure here, we got some lab equipment here as we scroll through it, okay? So a couple things I'm gonna do, I wanna break down each question, and I wanna remind you the structure of it. The first three questions are where you get the majority of your points. The first three questions, remember the total free response is 36 points, and the first three questions are 30 of those 46 points. The last four questions are only worth 16 points. So you're gonna get the majority of points on the first three questions, and you're gonna spend the majority of your time on them, all right? So let's look at this test. And again, we'll kind of go back and forth from the key. All right, so again, this tells you the time you should budget. Now remember, for our final exam, this is gonna be less time, and I gave you the time you should budget on your checklist, but for the AP exam, about 23 minutes. So, have your watch, look at the clock, and when you start question one, add 20 minutes to the clock, and you should be wrapping up around 20 minutes. And if you're not, you should at least move on and try to get your points, because maybe you're just spending too long on a question, and it's only worth a point maybe, okay? So a thing here, it says show your work, and you wanna show your work, because I don't know, if you've been taking these practice tests, you notice that sometimes they give you a point for showing showing that that moles of this, you're using moles of this to figure out moles of something else. And the answer is moles of that something else, but you get a point for showing that you calculated moles of something, of this. So show your work. Remember, it reads down, so if you show the work, if you show your calculation setup, and you might be just using the wrong number from a previous answer, you could still get full credit for that one, because your logic is right, your reasoning is correct, you're just using an incorrect number, okay? So just, keep that in mind. So show your work, and it says pay attention to significant figures. Now remember, that doesn't mean that you're gonna get points taken off if you have the incorrect sig digs. If they specifically say in the individual question, you need the right number of sig figs, then you need the right number of sig figs. But please, just pay attention to sig figs. It's not that difficult, okay? It's something we've talked about since day one of Chemistry 1. If you took honors chemistry, we talked about significant figures, okay, on the first day. So I don't think it's that difficult to ask you to do that, all right? So, and if you, when in doubt, I guess round to 3. I don't know, but you shouldn't be in doubt. Okay, so here we go. All right, another thing to break down is, okay, we got question 1. Remember, this whole thing is gonna be worth 10 points. So we got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 prompts. So that means 2 of the prompts are gonna be worth 2 points. I don't know which 2, probably not A, because you're just identifying hybridization. But if you have to justify, then maybe it's a point for the right answer and then a point for the correct justification, okay? Or maybe if it's a stoichiometry problem, maybe it's a point for figuring out moles of the reactant, and then a point for correct calculation of product or something like that. So think about that, all right? So most of these prompts are just worth 1 point. So if you have no idea, make something up, plug it in, and run with it, all right? So it says urea, it gives us the formula, it shows us the structure used in chemical fertilizers. The complete Lewis dot electron diagram for urea molecule is up here. Identify the hybridization of the valence orbitals of the carbon atom of the urea molecule. So you go to carbon, 3 domains, 1 bonding domain, 1 bonding domain, 1 bonding domain, so 3 total domains, so sp2. Okay, we go to our key, sp2. Okay, let's, while we're at it, let's go ahead and, so the carbon's sp2, this nitrogen would be sp3, this nitrogen would be sp3 because it has 4 total domains, and the oxygen would also be sp2 because it has 1, 2, 3 domains. So the carbon's sp2, the oxygen's sp2, that nitrogen are sp3s. This nitrogen is trigonal pyramidal, this nitrogen's trigonal pyramidal, this carbon's trigonal planar. So just kind of thinking about all the different types of questions. But there you go. Remember, if they asked about this bond angle, it's not 180, it's 120 because around the carbon it's trigonal planar. Okay, so just those types of questions, all right? So in the next one, we want to draw a hydrogen bond. So remember, we used dashed lines, and it's telling you, used dash line. They give you an example, 3 dashes, or I guess 4 dashes there. And it says draw 1. So there's a bunch of places you could draw a hydrogen bonding between a water molecule and a urea molecule. But remember, the strongest interaction is going to be fond bond to fond bond. So here's an oxygen side of a water molecule, so you know that's a negative dipole. You don't have to don't write the negative sign and the positive sign. I'm just showing you how this works. And then here is the hydrogen if we look at the structure, that hydrogen right there is that right there, okay? And if we just draw a dashed line from that oxygen to that hydrogen, if we just drew a line like that, that would be a hydrogen bond. You could draw it there, you could draw it there, you could, if you showed this hydrogen, make sure you don't connect this hydrogen with that hydrogen, make sure you connect that hydrogen with that nitrogen, that would be one, or this oxygen with maybe that hydrogen, okay? So a lot of possibilities, there we go, all right? So the dissolution, so that just means dissolving of urea, is represented by the equation above. So solid urea goes to aqueous urea. A student determines that 5.39 grams of that compound, they give you the molar mass, so you don't even have to calculate it, can dissolve in water to make a 5 milliliter solution. Okay, and part C, calculate the concentration of the urea in a saturated solution. So there we go. We just have to convert this to moles, convert this to liters, moles divided by liters. So we would take our 5.3 grams, 39 grams, divided by the molar mass that they gave us, and divide by 0.005 liters, not 0.05, okay, because we have to move the decimal place to the left 3 times, and we get a high concentration, okay, so it's okay, but that's what we would get, 17.9 moles per liter. Let's go back to the question. Whoops, wrong thing. Here we go, let's go back to here. So 3 significant digits, 3 significant digits, 4 significant digits. So I'm going to limit myself to 3. Even though the question doesn't say write significant digits, like if you wrote 18, I think you would get credit there, but again, we're allowed 3, so use 3, okay? So 17.9 molar. Okay, the student also determines that the concentration of urea in a saturated solution at 25 degrees Celsius. So remember, part C was at 20, so as we increase the temperature, we got more molarity, we got a higher molarity. So it got more soluble as the temperature increased. So temperature, increase in temperature here favored the forward reaction. So as I added heat, more of the solid dissolved, and so that means heat is a reactant. That means we have an endothermic process. So based on this information, is the dissolution of urea endothermic or exothermic? We just answered the question, but we need to justify using Le-Chatelier's principle. So I would imagine that A was 1 point, B also 1 point, and C probably just 1 point. But D might be worth 2 points, one for correctly saying endothermic, and then 1 point for the correct justification. So remember, you don't know if it's 1 point for both, or you get 1 point for each. So take a guess. If you didn't know, and you didn't know how to justify, at least say endo or exothermic, and maybe you get a point if you guessed right. All right. Whoops. So where is my? Okay. I need to. Okay. So endothermic, an increase in temperature favored the products. Okay, you probably want a little bit more in terms of Le-Chatelier's principle. So you might want to say an increase in temperature is adding heat. We added heat. The reaction shifted towards the reactants, or sorry, shifted towards the products, and that means heat is a reactant, which means it's an endothermic reaction. Okay, so I think this, remember, I'm showing you my answer key. I'm answering as fast as I can. I think I got the point for endothermic, but I think I need a little bit more in terms of Le-Chatelier's principle. When they say Le-Chatelier's principle, maybe use that word shift. So I'm a little wary of my response there. I would say an increase in temperature means we added heat, and adding heat caused a shift towards the right. That means heat's on the left. Heat's a reactant. So endothermic. All right. So I think I needed a little bit more in my explanation there, especially because they told me make sure you use Le-Chatelier's principle. Okay. So let's go back here. All right. So the equipment shown above is provided so that students can determine the value of the molar heat of solution. So delta H. So basically the delta H of this reaction. Okay. Knowing that the specific heat of the solution is 4.18 joules per gram degree Celsius, so the same as water, list the specific measurements that are required to be made during the experiment. So be careful here. It's not asking you what to do with those measurements to actually calculate delta H. So you don't have to do that. Just what measurements do you need to take during lab, not the calculations you do with those measurements after lab. So this is where kids might waste time doing stuff that is correct. I mean, you could correctly calculate, the delta H of reaction if you were given those measurements, but it's not asking you what to do with the measurements. It's just what measurements do you need to take during lab. So calorimetry lab, you would need to know the mass of urea that you're going to dissolve, the initial mass of the water in the cup. So remember, you could say, if you wanted to say volume here of H2O in the cup, then you would have to say, assume the density of water is 1 gram per milliliter, because you need to know the mass of water in the cup initial. You need to know the initial temperature of the water, and then the final temperature of the solution. And because you've already indicated that it was endothermic, as the reaction goes, the temperature is going to decrease because, again, we're monitoring the temperature of the surroundings. So if you wanted to be detailed, you could say the lowest temperature reached when these two things are mixed together. So those are the only measurements you would need. Don't say what you would do. Yes, you would do final minus initial to get your temperature change, plug it into Q equals MCAT to get your Q, flip the sign of Q to get the right sign of delta H. This one should be positive because we know it's endothermic. And then take that energy, divide it by 1,000 to get kilojoules, and then divide it by the moles of urea that reacted to get energy per mole. That's what we would do with those measurements, but these are the only measurements we would have to take for the lab. All right, so be careful there. All right, so let's go to the next one. So part F, the entropy change so I'm guessing E would probably be 2 points. There'd probably be 1 point for correctly saying you needed to know, one of those measurements, and 1 point for another one. Probably, I don't know. The entropy change for the dissolution of urea is 70.1 joules per mole Kelvin at 25 degrees Celsius. Using the information, the table above, calculate the molar entropy of this. So this one's really easy. It's just delta S equals products minus reactants. You know what delta S equals, so it would be 70.1 equals X minus that. And you would multiply these by their coefficients, but their coefficients are 1 in the balanced equation. So it's just solving for that unknown. But you got to remember products minus reactants. The answer, the formula for how to calculate this is on your formula sheet. So this what F should be an easy one to do. So we would just say the delta H reaction equals X minus. So this is our unknown, and over here is what we do know. So X minus that, and then we would solve, and we get 174.7. Now it should also make sense that aqueous urea would be more disordered than solid. So we should be expecting a number here that's greater than the 104.46. All right, so let's go back to the test. All right, so using a particle level reasoning, explain why the molar heat of the entropy of solution is positive. All right, so remember, particle reasoning, usually you want to talk about the motion of particles. So just, aqueous particles, solid particles are in a fixed position, aqueous are able to flow. So there's more randomness in the aqueous solution, okay? And then if we go to part H, the student claims that delta S for the process contributes to the thermodynamic favorability of the dissolution of urea. Use thermodynamic information above to support the student's claim. All right, so we know that a positive delta S is what favors entropy change. So the student is correct, okay? But explain it in terms of thermodynamic favorability, so delta G, okay? So delta G equals delta H minus T delta S. Well, we know delta H is positive, and we know delta S is positive. And so what is making delta G negative? The fact that delta S is positive, okay? So let's see what we have on our explanation. You would say favorability is determined by the sign of delta G. Delta G equals delta H minus T delta S. When delta H is positive, like in this reaction, delta S must be positive and large enough in magnitude to make delta G negative, which indicates thermodynamic favorability. There we go. I think that's a really good explanation. So this is kind of something they would be looking for. All right. So this is part one. The next installment, we'll go over questions 2 and 3, and then we'll see how far else we can get with the next installment after that. All right. Have a good one.